In buildings and commercial facilities in Japan, if a current leakage continues in a low-voltage electrical circuit, an alarm will generally go off to notify you of an abnormality. Alarms are issued for each transformer, so it is necessary to investigate where the leak is occurring downstream. This video explains how to investigate earth leakage circuits for beginners in equipment management. This video was originally created in Japanese and has been translated into English using automatic translation. Please note that there may be inaccuracies. First, we will explain how to measure leakage electricity using an actual electrical circuit. The photo is an electric circuit I made for an experiment. The left side is the power supply side, where electricity is sent from the outlet. In the actual site, this location will be the transformer. The right side will be the load side where the lighting equipment is attached. Electricity flows from left to right, passes through the load, and returns from right to left. When you plug a lighting equipment cord into an outlet and turn on the equipment, electricity flows. There is a circuit that creates a branch circuit from the outlet, passes through the switch, and returns to the connection point. When you turn on the switch, the electricity that comes back is split. This branched electricity becomes leakage electricity. In the actual field, this leakage electricity is detected and an abnormality alarm is issued. The next photo shows a clamp meter attached to measure the flowing electricity. A clamp meter can measure the electricity flowing through a wire by pinching it. I numbered them 1, 2, 3 from the right side. Since the lighting equipment is on, 0.44 ampere of electricity is flowing through clamp 1. Clamp 2 holds both the wire going to the lighting fixture and the wire coming back. When there is no electricity leakage, the amount of electricity going to the lighting equipment and the amount of electricity coming back is the same. Therefore, they cancel each other out and the measured value becomes 0 ampere. Clamp 3 measures the electricity in the leakage circuit. Since the switch is off, no electricity is flowing, so the measured value is 0 amperes. The next photo shows the earth leakage circuit with the switch turned on. Clamp 1's electricity has been reduced from 0.44 amps to 0.33 amps. This is because the amount of electricity flowing through the leakage circuit has decreased. For clamp 2, the electricity has increased from 0 ampere to 0.08 ampere. This is because the electricity that flows into the lighting fixture is 0.44 amperes, but the electricity that returns is 0.33 amperes, so the difference is measured. For clamp 3, the electricity has increased from 0 ampere to 0.06 ampere. This is because the leakage circuit switch was turned on, so electricity is flowing to this side as well. The measured values for clamps 1 to 3 do not match the calculations due to errors in the measuring instruments. The current value measured by the earth leakage fire alarm that monitors the current value of the Class B grounding of the high voltage transformer, which will be explained later, is clamp 3. If this value exceeds the set value, an alarm will sound to notify you of an abnormality. In an actual on-site investigation of the leakage location, we measure all the wiring connected to the load, such as clamp 2, and check the measured value. In a circuit with current leakage, the current value is measured as shown in the photo. If there is no leakage, the current value is 0. The above is an explanation using actual photos. I will explain this with a video of actually turning the circuit switch on and off. With the ground leakage circuit switched off, turn on the light fixture. The value of clamp 1 is now 0.48 ampere. Next, turn on the switch on the earth leakage circuit. A current leak is occurring. Clamp 1 reading has dropped to 0.35 amps. Clamp 2 reading rose to 0.09 amps. Clamp 3 reading rose to 0.07 amps. When the measured value of clamp 3 exceeds the set value of the earth leakage fire alarm, an alarm will sound to notify you of an abnormality. Turn the ground leakage circuit switch back off. You can see that the measured values of clamps 2 and 3 have become 0, and the measured value of clamp 1 has returned to its original value. The slight difference in the numbers is due to instrument error. This concludes the explanation using actual photos and videos. The figure below is an electrical circuit diagram that I drew assuming a typical building in Japan. This time I will explain the method for investigating earth leakage, so I ignored the direction and phase of the current when creating it. Let me explain. Inside this broken line is the high voltage power receiving and substation panel. VCB52R is a power receiving circuit breaker. Trail 1 and TR2 are transformers. Converts 3-wire type 6600 volts to single-phase 3-wire type 200 and 100 volts. ELR1 and ELR2 are earth leakage fire alarms. Abbreviation for earth leakage relay. MCB 11, 12, 13 and MCB 21, 22, 23 are low-voltage circuit breakers. Inside this broken line is the power distribution board for each room. I named them L1 and L2. Each has a main breaker. Below that, there is a branch breaker. The numbers are 101, 102, 103, and 104 in order from the top left. The equipment was also numbered from A to F. B, D, E, F are grounded equipment. It's the same feeling as attaching a ground to a household washing machine. Now, I will explain how to investigate when an earth leakage alarm is triggered. The earth leakage fire alarm is activated when a current exceeding the set value flows through the Class B grounding wire of each transformer. The screen is an image of the flow of electricity in a state where there is no leakage. 5 yellow circles are coming out from TR2. When it reaches each device, it turns into a blue circle and returns to TR2. Since 5 go out, 5 come back. The green circle of leakage current is not flowing through the ELR. Next, we will explain the situation assuming that equipment B has a short circuit and electricity is leaking. There are 5 yellow circles from TR2, but since device B is leaking, the blue circles become smaller and the green circle returns to TR2 from the ground wire. Since the green circle electricity flows through the ground wire of TR2, the leakage fire alarm of TR2 will sound. When the alarm actually goes off, there is a leakage somewhere connected to TR2. However, you won't know if there is a current leak in device B unless you investigate. This is a measuring instrument used for earth leakage investigation, but a clamp meter is required to measure leakage current. A clamp meter is a measuring device that measures current by clamping a wire. There are 2 types, one with a large gripping range and one with a small gripping range. Both are often required, so be sure to check in advance whether you can purchase them if they are not available on site, or where you can inquire and rent them. At the site where I used to work, they didn't have the large type, so they only had the small type, and we all searched for about 6 hours to find the leak, but we couldn't find it. After that, I borrowed a large type from another department and was able to locate the leak within an hour. Preparing your tools is important for any job. First, measure the leakage current in the ground wire of TR2. This is to find out if the fire alarm may be malfunctioning and how much current is leaking. Next, pinch the 3 breaker wires closest to TR2 with a clamp meter. A circuit that is leaking current will display a large current value. This is because current is leaking, so the amount of output and return does not match. A normal circuit has both the wire going to the device and the wire returning, so if there is no current leakage, a value close to 0 will be displayed. Device B is leaking, so if you pinch all 21 wires of the MCB, a large current value will be displayed. In the diagram, 2 yellow circles pass through, but only one blue circle and a smaller one return. Device B has a current leakage, and part of the blue circle becomes a green circle, passes through the ground wire, goes through the ground, and returns from the ground wire of TR2. For circuit 104, which is connected to device B that is leaking, you can check the leakage current by holding the 2 wires with a clamp meter. If the leakage point is in device B, disconnect device B from the power circuit and turn on the breaker to recover. If there is a current leakage from the power circuit, repair that part. This concludes the brief explanation. I hope this video is helpful to you.